Okay, now we're going to do the next example, which is on your calculator. So, hope you wrote down the problem. It's x squared plus 5x minus 7. So you're going to go to your y equals, which is right here, and you're going to type it in to the y equals. So you need x, which is, remember we have a special button by alpha for x because we use it so much. Same thing for squared, it's down here. And then we have plus 5x, so plus 5, and then the x again, and then minus 7. So once you have that entered, go ahead and hit enter, and then you're going to go to graph. Then we're going to look at our graph. Remember the default window is from -10 to 10 on both x and y, but on these newer calculators I think it changes. So we can't see the vertex, so if you were trying to see the vertex we would want to adjust our window. But we don't care about the vertex this time, we care about the x-intercepts. So if you look at this bigger screen over here, we can see the x-intercepts a little less than 1, 2, 3, 4, 5, 6, and a little more than 1. But what we're looking at this time is estimating, not just saying it's between two numbers, but actually estimating it to the nearest hundredth. So we are going to go to the table. So you're going to hit second, and then graph again, because since we press second, we're actually using the table function. And then you'll be brought to this table. What we want to do is to find out where a sign change occurs. So if you remember with the last example, when we didn't have an exact value for x that made y equal to 0, that we knew a 0 occurred between a positive output and a negative output. So if you look over here, we have, I'm going to scroll over here, we have -7, -1, and then it jumps to 7. So in between -1 and 7, it had to hit 0 because it's not a graph that just jumps from point to point. It's connected and continuous. So I know a 0 happened between 1 and 2. I also know if I keep going up, it's going higher and higher. So I know the 0 is not that way. So I'm going to go back the other way. And if you looked at your graph before you do this, you will see anyway that it is not higher than 10. It's between -7 and 6. For some reason it's not letting me go back further here. I don't know why. Yep, it's frozen on me, so just give me 1 second until it stops freezing. Okay, so apparently you can't go up when you're on the Y column on these new calculators. So it'll just take you to that Y1. So if you're trying to go back up, you need to go arrow over left to the X side, and then you can go up and down. So anyway, we can see that the Y's are now negative, negative, and then they're coming back up to positive. So again, we have that same sign switch between -1 and 7. So I know another 0 occurs between -6 and -7. So I could estimate that it's right in between, or using my graph, no, it's closer to, it's a little above 1 and a little below -6. But we are going to estimate it by changing how our x increases. So right now the default of the table is to increase by 1. So you can see that we're going up by integers and increments of 1. We're going to change that. So what you need to do is go to second, and then you're going to hit window, which we're actually using the function table set. We're going to change our table settings. So we don't really care about the table start because we can move it up and down to change that. But what you want to do is arrow down to this triangle table. This means change. So it's how your x value is changing. It's set to change at 1. We're going to change it to 0.1. So we're going to go up by tenths this time. And this auto means that we're going to tell it where to start and what to go up by, so it'll automatically do that. That's what this auto is. And then for dependent auto, it will automatically tell us the y as well. Otherwise, if we left this, if we put this as ask, we would put in the x values, which could help too if you don't want to keep coming back and changing the screen. But for right now, we're going to stick with this. So go back to second and then graph, which is table. And now you can see that they're increasing by only tenths. So what this allows us to see is, again, from a negative to a positive output, but we're going to have a better estimate. So we know it's between -6 and -7, so I'm going to bring up those values here. Now, so before, before it was -6 and -7, but when we go up by tens we have a whole lot more values to choose from and to find a sign change. So I can see it's all positive here, positive, and then it changes to a negative from -6.2 to -6.1. So that's an even better estimate. I know it's between -6.2 and -6.1. And then if I keep going up, I will be able to see the change when it's between negative, or for +1 and +2. So I got annoyed with scrolling. So if you go back to second table set, you can tell your table where to start. It's really slow on the computer. It shouldn't be as slow on your calculator, but you can always go back here and start your table at a different spot so that you don't have to scroll as much. So now I'm at 1. So between 1 and 2, I can see before all I saw was -1 changed to 7. Now I see all these little values in between. So I know that a sign change actually occurs between 1.1 and 1.2. So I had -6 point, goes 6.1 and 6.2, or it was 2 and 3, and then 1.1 and 1.2. So now I'm going to go back to my settings here, my table set, so second window, and we're going to actually change it again to be even more precise to hundredths, so 0.01. So now we're going up by hundredths every time. I'm going to stick with my table start of 1 so that I don't have to scroll. I'm going to look at that one, and then we'll come back here so we can go to 7, or -6. So go back to second table, and then now look at all these negatives. We were between -1.1 and +1.1 and +1.2, so I'm going to go up closer there and see that the actual change is from, this is a very small number, this is -4 times 10 to the -4th. That's what that E means, times 10 to the power of whatever this number is. So now I can see that the actual change is between 1.14 and 1.15. I'm going to go back to my, so that's even a better estimate. So I'm going to go back to, and actually before we go back, the better estimate if you were to stop here would be 1.14, because this number is closer to 0 than this number is, because this is more decimal places out if you were to write that in standard notation. So go back to second table set again, and I forgot to, must not have hit second. I'm going to change my table start to -6, because remember that's where our other 0 is, and I don't really feel like scrolling that much. I'm going to put 0.2 because I think we were around there. And then go back to second table. Okay, so here, perfect. So it was between -6.1 and -6.2, and the actual change is from -6.15 and 6.14. So do you see these similarities? For the 1 it was 1.14, 1.15. So 6 was 6.15 and 6.14, except these were negative, the others were positive. So they do have similarities here. And so again, a better estimate would be -6.14. We're going to go one step further so that we can round to the nearest hundredth. Now, this is to the hundredths place, but to round accurately to the nearest hundredth, we have to go out to thousandths, because right now our hundredths are still estimates, but if we go out to thousandths, then our thousandths is the estimate and our hundredths place is for sure. So we need to go out to the thousandths place in order to round with certainty to the hundredths place. So we're going to go back to second table set, and I hit second twice, so second table set, and I'm going to stay at I'm going to change this to -6.14 since that was my closer estimate, and then I'm going to change my scale to go up by thousandths, so 0.001, and then go back to your table, second graph, and now we've got even more values. So it's increasing, it's getting closer to 0 here, so we're going to go, if we go up. If we go down, we're getting more negative. So we have to go up, because remember it was between 6.14 and 6.15. And here's the change right here between 6.14 and 6.141. This one's closer to 0, so 6.14 is going to be our first estimate, 6.14. And then we have to estimate our other ones. We're going to go back to table set and change our start value so we don't have to scroll as much, and change it to 1.14 was our better estimate. Enter, and we're still going up by thousandths. And again, our change between a negative and a positive, so we know 0 occurred between there, 1.14 and 1.141. So there's really an imaginary 0 here. So our better estimate is 1.14 because negative 4 times 10 to the negative 4th is closer to 0 than 0.0068. So that's it for that one. Our estimates are x equal to 1.14 and x equal to 6.14. And so we are confident to the nearest hundredth because we went to the thousandths place. While I'm here, I'm going to go ahead and show you how to find exact zeros, go over that a little bit. So we've got this in our calculator. So we're going to go to second calc, which is trace. And we're going to go to 0 because we're trying to find zeros, and what we're trying to estimate is this point right here and this point right here. So this is how you can estimate or check your solution. So what it's going to ask for you first is a left bound. So you need to drag it to the left of one of these points. So this means you're going to have to do this twice. So we're going to go to the left. Don't get too close because you don't want to overshoot it, but you can get a little closer than it was at first. Hit enter, then go to the right of that point, hit enter one more time, and it'll estimate at 1.14 was the estimate to the hundredths place, so we were correct. Then to do the second one, you got to go back to second calc again, and you can either hit 2 or scroll down to 0. Now we're going to do the other one, so I need to scroll over here, and actually if you can type in a number, so I know it's between -7 and -6. So if I plug in -7 and hit enter, that I chose that as my left bound. Then right bound, again, instead of scrolling, I can just type in my right bound, which is -6, hit enter one more time, and again it found -6.14 as our other 0, so we were correct when rounding to -6.14. And that's it for that one. You do have to do this on your homework. If you're still having trouble, there is a graphing, the section of the book where the problems are has an example with step-by-step directions. So consult that if you need some more help.